Hey everyone, and welcome to this explainer. Today, we are going to completely demystify exactly how researchers systematically take messy, real-world information and turn it into reliable, actionable data. Because, whether you're trying to analyze a centuries-old historical text, make sense of a chaotic modern social media feed, or just evaluate test scores from a language classroom, making sense of human communication and behavior requires some seriously rigorous tools. So we are going to build up a methodological toolkit together, one that beautifully bridges the gap between qualitative meaning and strict quantitative measurement, ultimately empowering you to decode the hidden patterns in literally any field.
Okay, let's just quickly run through our roadmap for today. Number 1, decoding texts, content analysis. 2, the art of coding. 3, the quantitative research approach. 4, designing a quantitative study. And finally, number 5, ensuring validity and reliability.
All right, Section 1, Decoding Texts, Content Analysis. Let's start with the very first tool in our kit, which actually requires us to act a bit like linguistic detectives.
So the absolutely crucial point to understand here is that this isn't just about reading closely or, offering an impressionistic opinion on something. Content analysis is a highly systematic method. And the best part, it can be applied to virtually any recorded form of communication out there. We're talking textbooks, essays, interview transcripts, even TV commercials. It acts as this incredible bridge method. You can use it quantitatively to just count the raw occurrences of specific words, or you can use it qualitatively to interpret deeper context and meaning. Ultimately, it allows researchers to handle massive volumes of text in a way that is transparent and objective.
And this perfectly illustrates the two distinct sides of our detective work. Are we just tracking the raw frequency of a word, kind of like just counting the pieces of a puzzle? That's conceptual analysis. A good example would be tracking exactly how often a specific grammatical structure pops up across an entire library of textbooks. Or, on the flip side, are we looking at how those puzzle pieces actually connect to find the deeper meaning between concepts? That would be relational analysis. Now, in the real world, a lot of studies actually blend both of these together. A researcher might first count how often a theme appears conceptually across a giant data set, and then zoom all the way in to closely read those highest frequency instances just to understand how that theme is actually constructed in its relational context.
Moving right along to Section 2, the art of coding. What's really fascinating here is how we actually put all that abstract detective work into a rigorous step-by-step practice.
When you walk through the basic procedure for content analysis, literally everything hinges on building a rock-solid coding scheme before you even think about analyzing your material. First up, you have to define your unit of analysis. Are you going to code every single word, every full sentence, or maybe the whole text as one chunk? Choosing the right unit is a huge deal. Why? Well, because coding at the individual word level might cause you to completely miss a sarcastic sentence, where the overall meaning totally contradicts the individual words used. After that, you develop your coding scheme, which absolutely must be mutually exclusive and exhaustive. That basically just means every single segment you're looking at has exactly one category it belongs to, no overlap and no leftovers.
When you're developing that coding scheme, you have to make a really vital decision. Are you going to look at manifest content? That's the explicit, directly visible words right there on the page. Counting manifest content is super reliable because, honestly, it requires very little interpretive judgment. Or are you analyzing latent content? Now, this is the underlying tone, the implication or the subtle meaning that a careful reader picks up on, even though it remains completely invisible in the raw text. Latent coding captures way richer meaning for sure, but it requires extensive, rigorous training for your coders to ensure everybody is interpreting those invisible assumptions in the exact same way.
To see how this plays out in action, let's look at a pretty fascinating worked example from our sources. Some researchers wanted to analyze gender representation in the reading passages of a very widely used English as a foreign language textbook series. By systematically coding every single named character across 40 different reading passages, they discovered something interesting. Male characters were depicted with a professional occupation 68% of the time. Now, looking at those explicit, measurable differences, the gap is incredibly stark. Males are at 68% and females are at just 41%. But because the researchers didn't stop there, they also used qualitative, latent-level coding. They found a secondary, totally hidden pattern. When female characters were actually shown in professional roles, their professional identities were frequently mentioned just super briefly before the narrative abruptly shifted. It essentially subordinated their professional achievements to domestic or family-related topics. Now, that is a crucial latent pattern that raw conceptual frequency counts alone would have completely missed.
Okay, on to Section 3,
the quantitative research approach. So we've successfully decoded the text and extracted the meaning. But how do we go about measuring the invisible by stepping fully into the scientist's laboratory?
This approach marks a very deliberate shift. We are moving away from flexible, emergent qualitative designs and stepping firmly into the deductive logic of predetermined structures and hypothesis testing. This is all grounded in a concept called positivism, which is essentially the assumption that a single, objective reality exists out there and we can measure it through careful observation and instrumentation. The researchers' main goal here? To minimize their own personal influence as much as humanly possible, using standardized instruments that are applied identically to every single participant.
The foundational building blocks of this entire approach are variables. You have your independent variable, which is the presumed cause that the researcher either manipulates or categorizes, and then you have your dependent variable, which is the presumed effect or outcome that you actually measure. But here is the really tricky part. You can't exactly put an abstract concept like motivation on a physical scale and weigh it, right? Because we can't measure abstract concepts directly, we have to operationalize them. We have to clearly define exactly how we will measure them in the real world. Like, say, turning the abstract idea of motivation into a concrete composite score on a validated 20-item questionnaire.
Once you've got your variables locked down, you need a research design. And these designs basically exist on a hierarchy of causal strength. Descriptive designs are at the baseline. They just survey what naturally exists in the world. Next up, correlational designs. These can identify if two variables are mathematically associated with one another. But if you want to make confident, ironclad claims about what actually caused what, you need an experimental design. Only true experimental designs, which absolutely must involve manipulating an independent variable and randomly assigning participants, can prove a direct cause and effect relationship.
We also have to classify exactly how we're going to measure our variables using these 4 levels of measurement. This is critical, guys, because the way you measure completely dictates the statistical tests you are allowed to use later. Nominal data is just basic unranked categories. Think gender or native language. Ordinal data has an order, like a beginner to advanced proficiency band, but the spaces between the ranks aren't mathematically equal. Interval data does have equal spacing, like a standardized test score. And finally, ratio data has equal spacing plus a true meaningful 0 point, like age or reaction time in milliseconds. If you try treating a simple ordinal 1 to 5 survey scale like it's a highly precise ratio, it can drastically distort your entire statistical analysis.
All right, Section 4, Designing a Quantitative Study. Let's really dive into how you actually walk through this highly structured process as a researcher, from start to finish.
So unlike qualitative work, which can evolve as you go, this predetermined structure requires you to plan practically everything up front. You must turn your topic into a highly specific question and write out your testable hypotheses. This includes a null hypothesis, which essentially assumes no relationship exists between your variables, and an alternative hypothesis, which assumes one does. And get this, you have to do all of this before you ever even see a single piece of numerical data. You plan your sampling method, you choose your instruments, and you literally have to select your specific statistical test before you start collecting data. You can't just go fishing for whatever statistical test gives you the results you want after the fact.
For instance, let's imagine a correlational study testing the relationship between foreign language classroom anxiety and oral proficiency scores. Neither variable is being manipulated here. By gathering data from, say, 150 learners using a validated anxiety questionnaire and a standardized speaking test, researchers might find a correlation of R equals minus 0.42. What does that mean? Well, that specific mathematical relationship proves that higher anxiety significantly associates with lower speaking scores. But remember, and this is a golden rule in research, because this is just correlational, we still cannot definitively say the anxiety directly caused those lower scores.
Bringing us to our final section, Section 5, Ensuring Validity and Reliability. We've gathered all this quantitative data and text analysis, but what steps actually ensure our methods are trustworthy? Because, let's face it, if our instruments are flawed, our numbers are completely meaningless.
Let's tackle reliability first, which basically just means consistency. If you're doing a content analysis with multiple coders, you can't just use simple percentage agreement to see if they match. Why not? Well, think about it. If you only have 2 categories to choose from, coders could agree a huge portion of the time purely by flipping a coin and guessing. You need robust mathematical statistics like Cohen's kappa, which actually adjusts for that random chance agreement. Generally, a kappa value above 0.80 proves your coding scheme is genuinely systematic and that your coders are truly consistently on the same page.
Now, while reliability is all about consistency, validity asks a tougher question. Are you actually measuring the right thing? You absolutely must ensure your instruments are valid by asking these 3 specific questions. Construct validity asks, does your test of motivation truly measure motivation, and not just something entirely different, like a student's desire to please their teacher? Internal validity asks, does your study design genuinely support a cause and effect claim that is completely free of outside interference? And finally, external validity asks, can your findings actually be generalized beyond your specific laboratory sample to the wider real world?
Be sure to keep these common pitfalls in mind as practical warning labels for your own research toolkit. Beware of vague coding categories where your coders are constantly disagreeing with each other. Never, ever skip reliability checks. You can't just present your data as objective fact without proving it first. Don't choose your statistics after looking at the data just to hunt down a favorable result. And watch out for the classic trap, assuming that just because 2 variables heavily correlate, one of them absolutely must have caused the other.
By bridging the gap between qualitative meaning and strict quantitative measurement, you now have the conceptual toolkit to uncover the truth in a highly systematic way. Whether you are tracking latent themes in historical documents or running rigorous experimental designs to test out a brand new teaching method, rigorous research demands structure. So, looking closely at your own professional environment right now, what invisible patterns are you going to measure first?